All right, my friends, are we ready? Let's review together. I hope you did it first to the best of your ability. When you're stuck, you watch the video, press pause, and keep trying it on your own first as much as you can. I am going to go really fast because you've already done the work. So I'm going to write it calculus friendly. I understand it's asking for the derivative. We can write dy by dx or y prime. So 1/2 copy, subtract 1 to the exponent, and then the hook, which is 2x minus 3. Use the limit definition to find the derivative at a point. So the limit definition at a point, as x approaches that point 1, we have the function x plus square root of x plus 3, subtract. Then you actually plug 1. I need to know what f at 1 equals. 1 plus 3 is 4, and the square root of 4 is 2. And then x minus 1 in terms of what you're looking for. There's the setup. Keep writing the limit notation until you plug in 1. Oh, I'm going to multiply top and bottom by the square root of x plus 3 plus 2. So the square root of x plus 3 plus 2. So the numerator, if I go root and times the root, they cross out. The square roots cross out and just leave me with x plus 3. And then I have minus 2. The denominator, I'm just going to put them beside each other. So we have the square root of x plus 3 plus 2. Not going to fiddle with that. Limit again. We're almost there. So 3 take away 2 is negative 1. And by multiplying by what's called the conjugate, the part I need removed gets removed. Right. So this gets removed. When you do remove, there's still 1 in the numerator. And at this point, we don't need the limit notation because we're substituting in now. So plug in 1. And then we have the square root of 1 plus 3 plus 2. And if you simplify that, the answer is 1/4. By the way, if you leave it like that, it's still full credit. All right. Next one, average rate of change. How do we find that? So just remind yourself what that means and then do it. So in this case, I already know the x coordinates from 2 to 1 means 2 take away 1. I have to plug in to find the y coordinates. So plug 2 in. So somewhere we have to go 2 times 2 plus 1 cubed. That's 4 plus 1. 5 cubed is 125. Subtract. Plug 1 in. That's 2 times 1 plus 1, 3 cubed, that's 27, and then that answer is 98. Equation of a tangent line. What does that mean? X, y, and the slope. So the x coordinate is 2, the y coordinate you plug in 2 and you get 4. The slope, I need the derivative. And so the derivative of x squared is 2x, and then you plug x into the derivative and you get 4. Most of the time these won't match, but they can match. And then from there you would write down the equation of a line. You'd write down y equals the slope and then x minus 2 plus 4. It's over. The intermediate value theorem, this is what it states. So on an interval, if this is continuous and we look at the y coordinate, so we look at f at 0, so plug in 0. If I look at f at 3, if I plug in 3, that if this y coordinate is in there, then that must exist somewhere between 0 and 3 where x is something to give me that answer if it's continuous. So at this point we make them equal to each other and then solve it, and that is my c value. So when c equals 2, the answer is 5, and that's in the middle of these 2 points. All right, turn the page. All right, this one's going to take a bit of work. So if I want to find the derivative, not at a point, but the general derivative of a function, the limit as h approaches 0, and we start with x plus h. So take out the x and put in x plus h, and then subtract the function, which is x minus x squared, over just h. So there's the setup. Now we have to do the algebra to simplify this. So I have x plus h minus, if I FOIL this, so if you drew a box and you multiplied it out, you would get x squared plus 2xh plus h squared. And then minus x, and then a minus is plus x squared. And now I'm going to fully simplify it. It's going to get a lot easier now. So x and minus x, negative x squared and x squared. So I'm left with h. I'm left with negative 2xh. I am left with negative h squared because you distribute that. Factor out an h. Notice I'm still writing limit notation. and I get 1 minus 2x minus h. At this step, we can remove the h from the denominator, which is what we needed, and then when you plug in 0 for h, you get your answer. Done. And if you take the derivative with shortcuts, it's 1 minus 2x. It matches. All right, this shouldn't have said 10 to 17. It just says these are grouped together. Awesome. So what's the function value at -3? That's the y-coordinate. It's 1. Don't go to the hole, go to the close point. What's the limit coming from the left? So from the left, what's the y-coordinate? And the answer is -2. What's the limit at -3? It doesn't exist because a limit does not exist at a jump. F at 3 is the close point, which is 2. What's the limit as x approaches 3? There's no jump here, so look at that and look from the right and left. They both agree they're approaching 3. When it gets there, there's a point that jumps, but the actual curve, the function, does not. So from the left and right, the y-coordinate is 3. That is a different than this. This is a jump. That is not a jump. All right, x at -1, the limit does not exist at an asymptote. Removable means the limit exists there. So at this discontinuity, the limit exists. So when x equals 3, they consider that a removable. If the limit doesn't exist, it's non-removable. So that's when x equals -3, and the other one is at the asymptote at -1. Can we evaluate limits? So we're going to factor. And notice these all cross out. So x squared take away 9 matches the top. I'm left with, and again, I should really write that limit notation. So don't forget to write the limit notation as you do algebra. So we have the limit as x approaches 3. We're left with 1 over x. So now when I plug in, now you don't write the limit notation. So the answer is 1/3. Here you can plug in 2 and get the answer 0. It's not undefined because when you plug in 2, it's not 0 in the denominator. Here, end behavior question, so power term over power term gives me -1/4. Here, a little trickier, power term over power term. So if I write this out, it's a right end behavior question. If I simplify it, I get x squared over 4. This is just a parabola, and so the right end is going to infinity, or you can say it doesn't exist. Both are correct. How do I do a limit here? 0 belongs to the top, so plug in 0. Ultimately, a limit is just a substitution question, and then we do algebra when you substitute in as indeterminate, 0 over 0. All right. Differentiate, fancy word, take the derivative. So the derivative here is 20x to the 4th minus 12x squared plus 1. Take the derivative again. I need it to be calculus friendly. So f at x is x squared plus 3x to the -1. So the derivative here is 2x minus 3x to the -2. And then that's 2 plus 6x to the -3. Find the limit here. This is indeterminate, so I have to factor it. And then after you factor it, they eliminate, and you're left is now you can plug in 2, and you get 1 over 5. To know if it's continuous, plug in 0 for x. So if I do that, I'm left with -3. Plug in 0 for x, I'm left with -a. So a is equal to +3. That's what would make it continuous. The derivative here. So I'm going to go 3 times 10, which is 30. Copy. Subtract 1 to the exponent, and then the derivative of -t. The derivative of 20 is 0, but -t is -1. That's the derivative. What is the rate of change is a fancy way of saying what's the derivative when t equals 10. So that means to the derivative you plug in 10 and then solve it. So that's 20 take away 10, that's 10. Squared is 100, that's -300. What units would we have? We have gallons per minute, which means water is leaving the pool at a rate of 300 gallons per minute. That's the rate the water is leaving. It's decreasing because you're draining the pool. That's why the rate is negative. What's the average rate of change of the quantity of water? So that's AROC over the first 10 minutes. So the first 10 minutes means from 0 to 10. So those are my numbers I'm using. So we have 10 and 0. I plug that into here. So if I plug in 10, I get 300, right? No, 10, I get, let me try that. So 20 take away 10 is 10. 10 cubed is 1,000. I get 10,000. And then if I plug in 0, that's 8,000. So if I subtract that, I get 2,000 over 10, which is 200. So Q is already a rate. So this is going to be gallons per minute squared. This is going to be gallons per minute. So on average, it's 200 gallons per minute. Okay. How long will it take to drain the pool? So take the equation and make it equal. The pool is drained when there's no water left. This is just 200 gallons. So the question is, what is the average rate of the quantity of water? So the quantity of water is just gallons. So on average, how much water is in that pool over the first 10 minutes? On average, it's 200 gallons. How long will it take to drain the pool? So take that quantity. When the quantity is 0, there's no water left in the pool, and then solve it. So the answer to that question, if you think about it, is at 20 minutes. Why was that so quick? Because 20 take away 20, right? That makes that 0. So at 20 minutes, the pool is drained. All right, turn the page. So you're given a position equation. How do you find the speed at 4 seconds? So first I need to know the velocity. So I take the derivative to find the velocity. Then I'm going to plug in 4. But then I want the absolute value of whatever that answer is. That's what speed is. Now, in this case, when I plug in 4, the answer is already positive. So that's okay. It's 100 take away 64. And that's 36. And then the units would be in seconds and feet. So it's feet per second. I was looking at the games. So at 4 seconds, the speed of the object is 36 feet per second. All right, find the acceleration. So we need to take the derivative again. That's just negative 16. And then at 4, the answer wouldn't change. It's negative 16 because there's no variable to plug in. The answer is just negative 16, but the unit would be feet per second squared. All right, you're given a position equation. Find the velocity, so take the derivative. And then I want to find the acceleration. Take the derivative of velocity. For what values is the particle moving to the left? So take the velocity and make it equal to 0. So I'm going to factor out a 3t. And I'm left with t minus 2. So the two values I'm looking at, my critical numbers are 0 and 2. Draw a number line. For velocity. So if I plug in negative, it'd be a negative times a negative, which is positive. If I plug in positive 1, I get a positive times a negative. If I plug in 3 or 4 or 5, I get a positive answer. So it's definitely moving to the left from 0 to 2 seconds. Or what is it? Do we even have values there? From 0 to 2. Displacement from 0 to 4. So we need the position equation. So the position equation gives me displacement. So you plug in where it ended, which is at 4. Subtract where it began, which is at 0. So we don't have to simplify it. Now, if I plug in 0, the answer isn't 0. But if I plug in 0, the answer is 5. So that's why I have a 5 here. So you could solve it if you need to. But there's the displacement. What's the total distance it traveled? Well, to understand total distance, every time it changes direction, I need to know. So from 0 to 4, it changes direction at 2. So we need to know the distance from 2 to 0 that it traveled, and the absolute value of that. And I need to know the distance from 4 to 2. And again, it's the absolute value of whatever that number is, and then we add those up. So we don't have to simplify it. Absolute value bars, S at 2 is 2 cubed minus 3, 2 squared, plus 5, minus 0 again, which is 5, plus 4. That's 4 cubed minus 3, 4 squared, plus 5, minus, use parentheses, 2. That's 2 cubed minus 3 times 2 squared plus 5. And that's it. So we don't need, if there was units, I'd include it, but I don't need to simplify that answer. So that's the total distance the particle went. All right, let's take derivative again. So write it friendly to the 1/2, and then the derivative would be 1/2, 3 minus 2x, subtract 1 to the exponent, and then the hook. Done. Here, this is called the quotient rule. What is the quotient rule? It is the bottom times the derivative of the top minus the top times the derivative of the bottom, and then the bottom squared. This is the product rule. That's the first times the derivative of the second. So 2 times 1 in front, and then subtract 1 to the exponent. I don't need that. And then the hook minus the second times the derivative of the first. This one, and I might do it here a little bit on the right, to take the derivative, we do it implicitly. So the derivative of 3x squared is 6x. This is the product rule. So the first times the derivative of the second plus the second times the derivative of the first. The second one would be 10y, but it needs the hook y prime, and then 1 would just be 0. And then the y primes, I'm going to factor out a y prime from negative 2x and from 10y. That becomes negative 6x. Where's the other one? That's negative 2, so it becomes positive 2y, and then I divide. So I have negative 6x plus 2y over negative 2x plus 10y. You don't have to simplify. You could divide everything by 2, but you don't have to do that. All right. So here you have a graph. I want to graph an accurate graph of the derivative. So if I look here, what are the critical numbers here? So here we have a low point at negative 3. So this is decreasing to negative 3, and then at 3 it increases. Then after 3 it decreases. So it's going to be below, above, below. These are lines, so slopes matter. So the slope here is the derivative. So the slope here is negative 1. Then the slope here is positive 1. And then the slope here, again, is negative 1. So what would that look like? So first we go to negative 1. All the way to, did I say negative 3? I meant 0. That's 0, even though it says negative. It's 0 and 3. 0. So it's up to 0, and then there'll be a hole there. So negative 1 up to 0, and then at 0, it's now going to be positive 1 up to 3. And then at 3, it goes back again to, so it's negative 1, and then it's 1, and then it's negative 1. So that's a graph of the derivative of this. And they're holes. The derivative doesn't exist at that corner. All right, horizontal tangents. If I see the word tangent, that means derivative. If I see horizontal, that means the slope is equal to 0. So the slope is equal to 0. So what's the derivative? Take the derivative equal to 0 and then solve it. So the derivative first is 12x squared minus 12 equal to 0, and solve it. So I get two answers, positive and negative 1. Then I take that answer and I go back in to find the y coordinate. So it said the points. So at positive 1 and negative 1. And if I plug in positive 1, I get 4, take away 12. I think I got it. If I take negative 1, that becomes a positive 12. So it becomes 4, take away, so negative 1. So it's negative 4, positive 12, positive 8. I got it. My brain can do it. So at these 2 points, they're hard. In other words, there's turning points at those 2. Hey, can we do implicit again? So that's 2x. This is going to be the product rule. So you have the first times the derivative of the second I'm always going to remind you, you have to do these questions first, right? Then see if you did them right. The second times the derivative of the first. The next is negative 6y, but it needs a y prime, and then 4x is just 4. So there's step one. Look at each one. Do you understand where it comes from? Then factor out a y prime from 5x. Factor out a y prime from negative 6y. Everything else is going to the right side. So we already have a 4 there, so we're going to subtract 2x. I'm going to subtract 5y. And then the last step is I'm going to divide. And that's it. And you have your answer. So the derivative is this. There's nothing that would simplify that. All right, equation of a tangent line. That means x equals 2, y is negative root 3, and then the slope is the derivative of that. So that's 2x, that's 2y prime is equal to 0. So if I get y prime by itself, it'd be negative 2x divided by 2. So it's 2y, y prime, sorry. So this will be 2y. So it ends up being negative x over y when you get it by itself. So the slope then, if we plug in, is 2 over, now a negative times the negative is going to be positive root 3. We don't have to write it any prettier. And so the equation would be 2 over root 3, x minus 2 minus root 3. Done. We don't have to rationalize it. All right, the graph at the right is a velocity or rate graph. When is this object's acceleration equal to 0? So for velocity, acceleration is derivative, is the slope. So where is the slope 0? And it's between 2 and 4. When is the object moving left? So for a velocity graph, it's only when the velocity is negative that it's moving left. So where is it negative? From 7 to 9. Not including 7, but yes, including 9. Because at 7, it's 0. What is the speed of the object when t equals 8? Well, this is velocity. So at 8, the number is negative 1 meters per second, but speed would mean it's the absolute value of that. So the velocity is negative 1, but the speed would be the absolute value, which would be positive 1 meters per second. What is the acceleration at 6? So acceleration means the derivative of velocity. Derivative means slope. So at 6, what's the slope of this line? Go down 1 and to the right 1. That's negative 1 meters per second squared for the velocity, or for the acceleration. A point moves along the line x plus 2y equals 2. Find the rate of change of the x coordinate if the y coordinate is increasing at 2 centimeters per second. So this is a related rate question. So I'm going to take the derivative with relate to time. So the derivative of x is 1, but it needs the hook dx by dt. The derivative of 2y is 2, but it needs the hook dy by dt. And the derivative of 2 is 0. And then I plug in what I already know. So how fast is x moving? That's what I'm looking for. So 1 times this is just dx by dt. How fast is y moving at 2 centimeters per second? So it's and it's increasing. If that said decreasing, it would be negative 2. And that's it. There's no other numbers to plug in. So how fast is x moving? And the answer is x is decreasing, right? Because it's negative. At what rate? At a rate of 4 centimeters per second. All right, you're given a velocity function. Find the interval where the particle has increasing velocity. So when is this increasing? I need to take the derivative. So the derivative of that velocity or acceleration is just negative 2, and that means never. So because the answer is always negative, it's never increasing. When is the speed increasing? Well, that's the absolute value of that, and that means always. Because the absolute value of negative 2 is positive 2. So it's always, the speed is always increasing, but not the velocity increasing. Okay. Water is draining from a conical tank. That's a cone. Can I draw a cone? There's a cone. At this rate. The tank is built in such a way that the radius is equal to the height. the radius is equal to the height. Find the rate at which the height of the water, so I'm looking for the height when the height is 5. So I'm going to take this equation, and there's too many variables. So right away I'm going to take out, and I need h to stay. So I'm going to plug in that h is equal to r. So take out the r and plug in h because they're equal to each other. So I have one variable. And then I'm going to simplify this. So h squared times h is h cubed. Now we're in a position to take the derivative with respect to time. So 3 times a third is 1. Subtract 1 to the exponent, and then we have dh by dt, the hook. In the question it says that this is the volume. The rate of the volume is 2, so dv by dt is 2. In the question it says the height is 5, so h is 5. And in the question it says find the rate of the height of water, so dh by dt is what I'm looking for. So this is 25 pi, so divide by 25 pi and you have your answer. So we're looking for this answer, 2 over 25 pi, and the rate would be, for the height, feet per minute. So that means the height of the water is increasing at this rate, feet per minute. All right, we got a bunch of stuff here. Second derivative, second derivative, second derivative, second derivative, second derivative. Which of the following must be an x-coordinate of the relative minimum? All right. I'm thinking. So it can't be this, because when the second derivative is 0, there's no minimum or maximum. So it has to be either greater than 0 or less than 0. So now those. I am guessing this. I don't know, because I feel like information was left out that is my fault. So first I need to give you this information. I'm going to do it right now. So is the derivative at 2 equal to 0? Like, is it a critical number? And what do we know about the concavity? It's concave up. So that means at 2 it would be a minimum. So I'm going to add that information. It's my bad. The next one, let's say the first derivative at 3 also is equal to 0. Again, it's concave up, so again at 3, it's a minimum. Let's do it again, and let's assume, and I should have given this, that the first derivative at 4 is equal to 0, so it's a critical number. At the same one, it's concave down at that point, so if it's concave down on a critical number, it creates a maximum, so there's a maximum at 4. So my bad, I need to give you more information. I'm sorry. Next, a person's holding a kite. Who says Mr. G Math can't draw? I can draw. And it says the string is being let out at a rate of 2 feet per second, and it's moving horizontally along here at an altitude of 105 feet. Assuming there is no sag in the string, and the rate of the string at which the kite is moving the string is 125 feet long. Okay, so do we know it's 5 feet above the ground? That's what I was looking for. So if it's 5 feet above the ground, really, if it's 105, we subtract, and really the number we're looking for here from here to here is 100 feet. Now it also says this for the string is 125 feet, but I'm going to tell you that that value changes over time. So as the string is being let out, that changes, but this does not change. So it's going constantly across, so this value stays the same. I'm going to give you some letters. I'm going to call one x and one y, and I'm going to write down x squared plus 100 squared is equal to y squared. Now at this point I can plug in that y is 125 squared. So that string is, and I can solve for x. I know. I wouldn't give you such large numbers, but it's good practice to go through. So 125 squared minus 100 squared. I think it's an easy number, honestly. Yeah, 75. Okay, so I need that number, but not yet. So now I have the numbers I need. I know x is that. I know y is 125, so I have those. Is there a rate? So what is that rate? The string rate. So that string is y. So dy by dt, the rate of the string is 2. So those things I know. I want to know the rate that the kite is moving. So the kite is moving like where x is, right? It's moving in that direction. So we're going to call that x. So dx by dt is how fast the kite is moving to the right. And that's what I'm looking for. So I'm going to take the derivative with respect to time and then plug in. So the good news is the derivative of this is just 0. And again, this is 2y and then dy by dt. And then plug in. So the x coordinate is 75. I'm looking for dx by dt, how fast the kite is moving. Y is 125 and dy by dt is 2. So to get this by itself, I'm not going to be very fancy. So I'm going to keep 2 times 125 times 2 divided by 2 times 75, and then the unit, and I know the 2's and this could simplify, would be in feet per second. And that's how fast the kite is moving. And I'm not trying to get fancier than that. All right, find the absolute minimum of this. The absolute minimum is a table of values question. And so we have -2 and 1 that go into that table, but also I need to take the derivative equal to 0 and find the critical numbers that would also be in that table. So that's going to be -3x squared and -12x equal to 0. And then we're going to factor out a -3x. And so my two critical numbers are 0 and -4. Now look again and go, okay, -4 I'm going to cross out because -4 is not in my interval. So this one I'm not going to test because it's not between -2 and 1, but 0 is. And then to all of these I'm going to plug into this equation. So 0, let me do that first, simple. 1 is -1 and -6, that's -7. Oh, this one will take a little bit more time. -2 cubed and -2 squared, so that's -8, negative is 8. This is 4, that's -24, so that's -16. Hey, I found my absolute minimum. So it's at -6. So the absolute minimum of this is -16. All right. All right, concave up. That's the second derivative. So the first derivative is 3x squared minus 4x. The next derivative is 6x minus 4 equal to 0. Add 4, divide by 6. And then that is where I draw a number line. I don't need to reduce it down. And then to this, if I plug in 0 or negative, whatever, it's negative. If I plug in this, it's positive. So this is where it's concave up. So from 4/6 to infinity, it's concave up. Find the intervals where a different equation is increasing. So f at x is increasing. So I already know the derivative. So take this derivative equal to 0 and find the critical numbers. So factor out an x. Factor this. And then the two critical numbers are at 0 and 1. So we're going to draw a number line for 0 and 1 for the derivative. So into the derivative, plug in -1. So a negative times a positive is negative. Plug in 1/2. And again, a positive times a positive, and then a positive times a positive. So this is increasing from 0 to infinity. So it's where the derivative is positive. All right, find the absolute minimum and the absolute maximum of that. So it's a table of values question again. So I'm going to start with 0 and 3. I'm going to take the derivative equal to 0 and solve it. So if I solve it, the answer is positive and -2. It's a difference of squares, and that's my two answers. Now, I only want 0 to 3, so the only answer in my interval is 2. And then I got work to do, a little bit of work. Plug in 0, and the answer is 0. Plug in 3. Let's see if I can do that. That's 27. Take away 36. Oh, -9. And then 2. That is 8. Take away 24, which is what? -16. So what is the absolute max? The answer is 0. What's the absolute minimum? And the answer is -16. So it's the biggest number and the smallest number. All right, mean value theorem is when I rock equals A rock. So if I want A rock from 0 to 2, that's 2 take away 0. Plug in 2, and it's 2/6. That's good enough for me. Minus plug in 0, and the answer is 0. So we have 2 over 6 divided by 2, which is 2 over 12. I can write that as 1/6 to make it easier. Then the derivative is the quotient rule. So that's the bottom times the derivative of the top minus the top times the derivative of the bottom, and then the bottom squared. And I'm going to make that equal to 1/6. So I have x minus x, that's done, and 4, and that's it. So all I have on top is 4, and x plus 4 squared is equal to 1 over 6. I'm going to cross multiply. So that's x plus 4 squared is equal to 24. I'm going to square root this. It's positive and negative, but I don't want the negative because I want it between 0 and 2. So it's just the positive value of root 24. I don't need to simplify it. And then subtract 4, and you have your answer. And that answer is between 0 and 2. So it's negative 4 plus root 24. All right. If I give you a derivative in a point, oh no, I'm missing something. Let's, again, right? It can happen. Can you tell me what f at 5 equals? So I'm missing this. So I'm telling you right now, what's f at 5? So to find f at 5, you start with the y coordinate of what you know. So our starting value is 4. And then you integrate, starting at 2, to what I'm looking for. And you integrate the derivative. That's the setup. Then I'm going to integrate, add 1 and divide, and integrate again from 2 to 5. And then that's going to give me my answer. Again, I'm not going to simplify it, so I'm going to plug in 5. Subtract, use parentheses. I'm going to plug in 2. And there's my answer. And so if I simplified it, that's what f at 5. So look at the setup and whether you can integrate and plug in and subtract. All right, the velocity of an equation is this. If the initial position is 10, what's the position? So very similar question. So the initial position is 10, and then I'm going to integrate this. Here, actually, I'm going to just integrate the velocity. That's better. So if I integrate the velocity, that will be negative 6t squared plus 14. So that means that's the position equation. We'll call it S. So we're going to add 1 to the exponent and divide, and then that's 14t plus c. And then if the initial position is 10, that means when this is a point then, so when you plug in 0, the answer is 10. So the answer is 10, plug in 0, so it means c is 10. So go back again, and you can simplify that if it's so simple, and you have your answer. All right, let's see if this is good. So you're given a composite. So this is really the chain rule. It says find the derivative at 2. So if I take the derivative of this, the chain rule is the derivative of the outside times the derivative of the inside, generically. Then we want to know at 2. So wherever there's an x, plug in 2. And then use the values to plug in. So first of all, what is g at 2? It's 4. What's g prime at 2? It's 6. And then what's f prime at 4? It's 5. And so the answer is 30. 5 times 6. All right, a point 32 is on the graph of that. Use that equation of a tangent line. How do I do linearization? First I need a tangent line. So x, y, and the slope. So the x coordinate is 3. The y coordinate is 2. The slope, the derivative of that, is 3x squared minus 6x. And then I plug in 3 into here for the slope. And I get 27, take away 18, that's 9. So I get the equation 9x minus 3 plus 2. And then I want to estimate at 3.1. So then into that equation you plug 3.1 and answer it. So that's 9, that's 0.1. So that answer is 2.9. Mean value theorem. So again, A rock equaling I rock. So from 1 to 4. So a rock from 1 to 4 is 4, take away 1. Plug in 4. Square root of 4 is 2, plus 4 is 6, minus plug in 1. Square root of 1 is 1, plus 1 is 2. So that gives me 4 over 3. And then I take the derivative. Now if I made this friendly to the 1/2, the derivative would be 1 and then 1/2 x to the negative 1/2, and then I would solve that. So how would I do that? Subtract 1. So 4/3 take away 1 is 1/3. That's what I would do first. Multiply both sides by 2. That the 1/2 is gone. That's 2/3 now is equal to 1 over the square root of x. That's how I'd write it. Instead of x to the negative 1/2, it's 1 over the square root of x. I would cross. So it's 2 root x equals 3. So root x equals 3 over 2. So x is equal to 9 over 4. And you have your answer. You square both sides. All right, an object moves with this velocity. Find the object's initial position is 3. So find the acceleration. That's the derivative. So the derivative is 4 times 5, and then subtract 1 to the exponent. The derivative of negative 4 is 0. So that's it right there. What's the position? We'll call that s. We have to integrate this. So if I integrate this, there is no hook there, because the hook would just be 1. So we need a 5. So all I have to do is add 1 to the exponent and divide. And then negative 4 would just be negative 4t. These 5s do divide out. And now you've integrated it plus c. It said the initial position is 3. So when I plug in 3 or 0, the answer is 3. Now when I plug in 0, the answer is not 0 here. So when I plug in 0, I get 1 to the 5. That's 1. This is 0, and that's c. So if I subtract 1, c is equal to 2. So now when I put it all together, the position equation is t plus 1 to the 5 minus 4t plus 2. And know that if I take the derivative of this, it should equal that velocity, which it does if you took the derivative. This one is from an exam you took, right? Here's a derivative graph. Where is there a minimum? So this goes negative, positive, positive, negative, negative, positive, positive, negative. So when I go negative to positive, that's a minimum. So we have a minimum when x equals negative 7. Where's another? Negative to positive, also at 5. And then where's the max then? Well, when I go positive to negative, so at negative 1, and again positive to negative at 9. And then where's the point of inflection? At the turning point. So the POI would be at negative 3, and the other turning point would be at 2, and the other turning point would be at 7. And there they are. Need a drink of water. Page 10. We almost done? Who made this big thing? This is huge. Here we go. Take the derivative. So we need to make it calculus friendly. And then we need to use what's called the product rule, which is the first times the derivative of the second with a hook. So I just copied x squared plus 1 and then the hook minus plus the second times the derivative of the first, which is 2. Done. Here I need to do the derivative and then plug in 2. So this is called the quotient rule. What's the quotient rule? The bottom times the derivative of the top minus the top times the derivative of the bottom, and then the bottom squared. And then I plug 2 in where everything is. So 2 squared plus 1, that's 5. And then that's 5 squared. This is 5 times 10, that's 50, whatever. That's a good enough answer for me. So you plug in 5 and then get your answer. All right, next. Before I integrate this, I'm going to multiply it. So root x times root x is just x. And then I'm going to write it friendly. So root x times root x is x. Root x times 1 is negative root x. And then friendly. So, and then I add 1 to the exponent, and that's it. Add 1 to the exponent and divide. add 1 to the exponent. Instead of dividing, I do the reciprocal and then plus c. Here I need to write it friendly. That's 4 minus 2t to the 1/2. The hook should be negative 2. It was a 3 and it became negative 2, so negative 3 over 2 is good. This goes away. And then I add 1 to the exponent and then divide, which is fine, or times the reciprocal. That's perfect. Notice all of these have plus c at the end until they have limits or bounds. I'll write it friendly. So that's 2x squared minus 3 to the negative 1/2 because it was from the denominator. This should have a hook of 4x. Instead, it has 12x. So what it was 12 over what it became, which is 4. So 12 divided by 4 is 3. Then I'm going to add 1 to the exponent. That's positive 1/2, divide or times the reciprocal, and then plus c. This one, boo. Why do I say boo? Because the derivative doesn't, I have to do u substitution here. So that's what u equals. Add 1 and divide everything by 2. And then the derivative here would be 1/2 du. And then I come back here. So 2x, that might be helpful. If I multiply times 2, so this is 1/2 u plus 1. So if I want to know 2x, so if I multiply everything times 2, right, it would be 2 times 1/2, which is 1u, and then 2 times 1, which is 2. That's way more useful. And then u to the 1/2, du. 1/2 can go in front. And then I'm still going to distribute. So I'm going to add 1. That's 3 over 2 and just 2u to the 1/2. Then I'm going to add 1 and divide, or the reciprocal. I'm going to add 1 and divide, or the reciprocal. And then the last step, you don't need to multiply the 1/2 through, is I need to put x back in. So 2x minus 1 to the 5 over 2. And then 2x minus 1, that's 4/3, right? 4/3 to the 3 over 2 plus c. Boom, go clear. All right, boo, we don't want to do a lot of those. All right, we have bounds here. So I'm going to do algebra here first. So this is really t to the 1/2. So if I do algebra first, this belongs to both. So 2 take away 1/2 gives me 3/2, and then 1 over that becomes t to the negative 1/2. So think through how I went 2 subtract 1/2, and then negative 1 over. So I just take that exponent and make it a negative exponent, and now it's friendly. And now I can add 1 to the exponent and the reciprocal. As soon as I do this, I don't do an integration sign. Add 1 to the exponent and the reciprocal from 1 to 4. And then you plug in. Again, I'm not going to simplify it. Done. Here, the hook here is 3, so it was a 1 and it became a 3, so it's 1/3. This goes away. We add 1 to the exponent and divide, and I'm integrating from 0 to 1. So I'm going to treat this as 15, so I'm going to plug in 1 over 15 minus plug in 0, and you have your answer. All right, integrate this. Add 1 to the exponent and divide. Add 1 to the exponent and divide from negative 1 to 1. We're going to plug in 1 first. I'll simplify. It's 2. Then plug in negative 1. And you have your answer. Trapezoidal rule, love it. 3 equal subdivisions. The width is top subtract bottom divided by 3. So that means each width is 1. Trapezoidal rule starts with 1/2 times the width. The first height, plug in 1. And you get 6 there, you get 2. Then double the next one. So if I plug in 2, you get 4, 9, that's a 1. Double the next one. So if you plug in 3, you get 9, take away 12. That's 2. And then one more time. 4 is singular, so if you plug in 4, you get 16, take away 16, that's 5. Done. All right, turn the page. Again, use trapezoids of unequal widths from 0 to 12. So my first trapezoid starts with 1/2. The width of the first one goes 0 to 2, that's 2. And then the two heights I add together are 3 plus 7. Done. Next one, 1/2. The next width goes 2 to 6, that's 4. And then add 7 plus 9, that's 16. The next trapezoid goes 6 to 12, that's 6. And then the two heights add are 9 and 15, and I have my answer. These cross out, and so when I plug in 5 and take the derivative, the answer is 0. Then when I plug in x, it's a substitution question. And then there's no hook. The derivative of x is 1 if you want, but you have to be careful of that. From a helicopter, 48 feet elevation above the ocean, flare, gun is fired upward, initial speed of that. How long will it take to hit the water? So the initial speed of the flare is 32. And it started at 48 feet above. So there's the acceleration. So the velocity, the derivative of that, in the initial speed, so when I plug in 0, the answer is 32. So again, when I plug in 0, the answer is 32. And then if I take that and find the position, so if I add 1 to the, if I integrate it, add 1 and divide, that's negative 16t squared, that's 32t. In the initial height, so if I plug in 0, the answer is 48. Then to this, I would make equal to 0 and find out when it hit the ground. So divide everything by 16, negative 16. And then when I factor this, I only want the positive answer. So this answer is 3, and this answer is negative 1, so I want 3. So at 3 seconds, it hit the water. Good question. Midpoint Riemann sum. 4 rectangles. So from 1 to 9. So 9 take away 1 divided by 4. That's 2. So the width of each one is 2. And then the first one, so if you need to draw a number line, you can, from 1 to 9. So every 2, so that's 3, that's 5, that's 7, that's 9. The mid of the first one is 2. So plug 2 in and you get 1/4. Then plug in 4 and you get 1/16. Then plug in 6 and you get 1 over 36. And then plug in 8 and you get 1 over 64. Done. All right, the growth, I don't know what that means. The graph at the right shows the speed of a function of a speed of a car. And it says write a sentence telling what the coordinates of point A represent in words. So A means at, in hours. In half an hour, the car is traveling at a speed of, what speed? 40 miles per hour. Using the graph shown, if it integrates from 0 to 2 is 80, write a sentence to know what that means. So if you integrate all this and the answer is 80, that means the first 2 hours, the total distance is 80 miles of the car trip, right? So that's what it means when you integrate velocity, total distance. This is different than before. What's the average value? You integrate. So from 0 to 2, we're going to integrate. Divide by the difference of the bounds. That's 1/2. So if I integrate this, it's add 1 to the exponent and divide. You get x minus 2 to the 5 from 0 to 2. And then plug in 2. Subtract, plug in 0, and you get your answer. All right, at every point of the curve that sloped, can you take the derivative and you integrate that? So if I integrate this and I write it friendly, the hook is 2x. It was a 1, it became a 2. So the 2x goes away. So it's 1/2. We add 1 to the exponent, divide or the reciprocal, plus c, and then you plug in that point, which is 1, and you plug in 0. So the 2's cross out, and I got 1/3. Plug in 0, I got 4, and that's the answer. Square root of 4 is 2. 2 cubes 8. 8 over 3. Subtract 1 to 8 over 3. 3 over 3 was it? Negative 5 over 3. So then the equation would be 1/3 x squared plus 4 to the 3/2 minus 5 over 3. All right, a region is bounded by this and the x-axis. So I'm going to do a little graph of that. So if I look here and I want to graph it, if I factor out an x, I get 4 minus x squared if I factor out an x. And then if I make each equal to 0, one answer is 0, and then the other answer, and it's in the first quadrant, would be positive 2 would give me 0. Did you see that? How 0 would give me 0, and then positive 2, if I plug it in and solve it, would also be there. And any answer between 0 and 2, like 1 or 1 would give me the answer 3. And it would look something like this. And so with the x-axis, so there is my thing. So if I had squares, I'd integrate from 0 to 2. The base is top subtract bottom. So it is 4x minus x cubed subtract 0. And then square would be squared. Semicircles 0 to 2, 1/2 pi, and then 1/2 that base, which is 4x minus x cubed squared. Equilateral triangles from 0 to 2, that's root 4 over 3, and then the base squared. And there you go. So you have each different way to find the volume. Here again, these cross out. So 1, that gives me 0, and then I plug in x squared. And then there's a hook of 2x at the end. Here I would multiply it out first. So you FOIL it, so it's x squared plus 2x minus 3 if you FOIL with a box if you like. And then add 1 and divide and integrate from there. Here we're gonna, the hook is 3, so I need 1/3. So we start with 1/3, the 3 goes away. You add 1 to the exponent and divide from negative 1/3 to 0. So you plug in 3 first. So plug in 0 first, I mean. Then plug in negative 1/3. And you have your answer. So plug in 0, subtract, plug in negative 1/3. Find the average value from 0 to 3. That's an integration question. Divided by the difference of the bounds, so that's 1/3. That's x cubed divided by 3. That's 2x from 0 to 3. So we have 1/3. We plug in 3 first. And then plug in 0. 0 gives you the answer 0. Done. That's the average value. Find the value it takes on. So I need the answer here. So it's 1/3. 27 divided by 3 is 9. 6. That's 3 plus 2. That's 5. So then I have x squared plus 2 equals 5. Subtract 2, and the answer is at square root of 3. It could be positive or negative, but from 0 to 3 it would be only positive. So at root 3, the average value is found at 5. What do we got? I'm looking at the time. I'm right there. Last page. All right, graph this. Negative x squared plus 1. Graph that. And the x-axis, got it. And shade it in. Got it. Set up, don't integrate, find the volume of a solid revolving around y equals negative 1. There it is. There's a space there. So here we go. And that's from negative 1 to 1. And there's 2 circles, pi r squared. The big radius is the curve down to -1. So it's negative x squared plus 1, subtract -1. And then the little radius is 0, subtract -1. Or +1. Done. First quadrant, x squared. Got it. 2 minus x. So 2 and then I got it. And the y-axis. So I shaded the area. And it says find the area. So that's top subtract bottom. So the top is, so we're integrating, where does they intersect? So I need to make them equal to each other to make sure I know where they intersect. So I'm going to add x and subtract 2. So if I factor this, that's +2 and -1. If I solve it, I don't want -2. This is the one I want. So because -2 is not in the first quadrant. So +1. So from 0 to +1, top subtract bottom. So the line is on top. Subtract the parabola underneath. Done. That's for the area. To find the volume revolved around the x-axis. So there's a space there. So 2 circles. The first big radius goes from the line down to 0. So it's just 2 minus x. And then the second one, so the big radius, and then the small radius is the curve down to 0. That's x squared minus 0. And there's your setup for the big radius and the small radius. Last question. If the base x of a right triangle shown is increasing at a rate of 3 inches per square and the height is y is decreasing at the rate, find the rate change of the area. So area is 1/2 base times height. In this case, they said the base is x and the height is y. Now, in this case, I need to take the derivative as I see it with respect to time. So the first times the derivative of the second plus the second times the derivative of the first. And whenever you take the derivative, when we're talking about time per second, it needs the hook dy by dt or dx by dt or d8 by dt, and then you plug in what you have. So I'm looking for d8 by dt. We're told that the x is 5 and y is decreasing at a rate of 2. And then y is 7. And then x, we have 1/2. X is increasing at a rate of 3, so that's +3. And then we solve it, and you have your answer. And then I'm done. So that's -5. That's 21 divided by 2, whatever. And so I put it together, and what do you got? And then that is in inches per second. It's area, right? So it's inches squared per second because we're talking area. What? We got to the end of it. Hey, I know that was super fast. I wanted to get it done in an hour, almost. Mr. G Math over and out. I'm proud of you for working, doing the best. I so believe in you that when you come in to take your final exam, that you're going to do great. You're going to do your best. You may not remember everything, but you're going to do better than what you would have done if you didn't work this weekend. All right.